Good evening, innovators and enthusiasts. Welcome to an exciting evening hosted by the Electronic Robotics and Innovation Club of General Sir John Kotalawala Defense University. We're thrilled to have you join us for our workshop on AI impact on the engineering sector and applications. Before we begin, please make sure you are comfortably settled and ready to immerse yourself in what promises to be an informative and inspiring session. Greetings, everyone. I'm Hansanumi Tihara, your guide for this evening's exploration into the fascinating world of AI. We have an exciting lineup for you, packed with insights and breakthroughs that are reshaping the engineering landscape. Tonight's event is a part of our larger initiative called GENESIZ 24, a series of events designed to ignite innovation and foster creativity in the field of robotics and electronics among Sri Lankan youth. We believe in empowering the generation of engineers to push the boundaries of technology. So sit tight and get ready to embark on this journey with us. To officially set the stage for our event, I'm delighted to invite our esteemed co-chair, Isuru Darshana, the project chair of GENESIZ 24, and also the assistant treasurer of ERIC, to deliver the welcome speech. Isuru, the virtual floor is all yours.
Thank you. Good evening, everyone. I'm delighted to welcome you all to this exciting workshop on AI impact on engineering sector and application, organized as a part of GENESIZ 24. My name is Isuru Darshana, and I am honored to serve as a project co-chair of GENESIZ 24. First, I would like to extend a special welcome to our esteemed speaker, Dulan Bamunuge, Associate Machine Learning Engineer at Rootcode. Dulan, we are thrilled to have you with us today and look forward to gaining insights, your vast experience and expertise in the field of artificial intelligence. Before we dive into session, let me give you a brief overview of what is GENESIZ and why we are hosting this workshop. GENESIZ is a dynamic competition organized by Electronic, Robotics and Innovation Club of General Sir John Kotalawala Defense University. It is dedicated to discovering young innovators who can deliver fresh and groundbreaking solutions to Sri Lanka's pressing challenges, designed specifically for university undergraduates across Sri Lanka. GENESIZ provides a platform for young innovators to showcase their creativity and problem-solving skills through idea pitching challenges and engaging games. This workshop on AI impact on engineering sectors and applications is a crucial part of our efforts to equip participants with the knowledge and the skills needed to excel in today's rapidly evolving technological landscape. As we navigate through advancement in technology and understanding AI's role and potential become essential for our growth and innovation. The application of AI in the engineering sector are vast and transformative, offering new solutions and the efficiencies that can revolutionize the way we approach engineering challenges. I would like to acknowledge and thank Rootcode for their collaboration with us, making this event possible. Your support is invaluable to us, and we appreciate your commitment to fostering innovation and learning. Throughout this session, we encourage you to engage actively, ask questions, and make the most of this learning experience. This workshop designed for not just inform but to inspire, equip you with the knowledge that can be applied in your academic and professional journeys. Thank you. Over to you, Pansulmi.
Thank you, Isuru, for that inspiring welcome. Now, let's dive into the heart of our session. Today, we'll explore how artificial intelligence is revolutionizing engineering, from automating mundane tasks to pioneering groundbreaking innovations. Hold on to your seat as we unlock the potential of AI in engineering. It is my pleasure to introduce our distinguished guest speaker, Dulan Bamunuge, a visionary in AI and machine learning. He will guide us through the transformative impact of AI on the engineering sector and share real-world applications that are driving change. Please join me in giving a warm welcome to Mr. Dulan Bamunuge.
Hi, Bansali. Hope I'm audible to all of you guys. All right. Good evening, everyone. So hope you guys are all doing great. So today, we'll take a look at the impact of AI on the engineering sector. So before we begin, I'll give you a quick intro into who I am. I'm Dulan Bamunuge, and I'm currently working as associate machine learning engineer at Rootcode AI. So without further ado, we'll start the session. Let's start the session by giving you a quick introduction into AI and ML. So first, start with AI. So AI or artificial intelligence. So AI refers as a simulation of human intelligence in machines. So AI enables machines to think and learn in ways that resembles human thought process. So if you imagine a computer system that can diagnose diseases, play chess, or even to drive a car automatically. So all those functionalities are powered by AI. Moving into machine learning, ML is a subset of AI. So ML focuses on developing algorithms that allow computers to learn from data instead of being explicitly programmed. So in here, I have highlighted this section without explicit being programmed. So what do you mean by that? So unlike in traditional programming, where we need to write explicit instructions for every task, in ML, the models learn from the patterns in data. This learning process enables models to make predictions, and over time, as they process new data, their performance improves. Okay? Along with these terms, AI and ML, you have probably heard this other term also, the deep learning or DL. So let's take a look at what deep learning is. Here, if we take a look into the definition, deep learning is a subset of machine learning that uses neural networks with many layers to model and understand complex patterns in data. So you may wonder what a neural network is. So if I give a very brief introduction into what neural network is, it is a computer model inspired by the human brain that processes information by passing it through layers of interconnected nodes. We call these nodes as neurons, and the objective of this structure is to learn patterns and make predictions. Right. So in my right side, you can see in the image a simple depiction of a very simple neural network with one input layer, one hidden layer, and one output layer. The functionality of this neural networks or the functionality of the collectively deep learning is to process large amounts of data such as images, speech, and text, and effectively aid in tasks such as image recognitions and speech recognition. So if we recap what we have learned up to so far, basically AI is machine designs machine designs to mimic the human intelligence. ML is a subset of AI that focus on developing algorithms that allow computers to learn from data without being explicitly programmed, right? And finally, DL is a specialized form of ML that uses deep neural networks to analyze and learn from vast amounts of data. Next, now we have a basic understanding of what AI, ML, and DL is. We'll take a look at the types of machine learning. So we have four main types of machine learning. First, we have the supervised learning. So in this approach, the model is trained on labeled data. This means that each training example is paired with an output label. The model learns the relationship between the input data and the output label. So for a simple example, if we are training a model to recognize cats and dogs in images, we provide that model with the labeled images of cats and dogs. So over time, the model learns to classify new images based on this training. The next type of machine learning is the unsupervised learning. In here, the model works with unlabeled data, identify patterns and structures within that data. So the model doesn't know the output in advance. Instead, it tries to identify patterns and structure within the data on its own. We can take example as the customer segmentation into different groups based on their purchasing behavior. Next, we have the semi-supervised learning. In here, this is kind of like a combination of both supervised and unsupervised learning. So in here, the model is trained on both labeled and unlabeled data. So it uses labeled data to understand patterns and then applies this knowledge that it gained from labeled data to make sense of the unlabeled data. For example, semi-supervised learning can be used to classify images where only few images are labeled. And then the model can learn from those labeled images, and it can categorize the unlabeled images based on that initial training that it got from the labeled images. The final type of machine learning is the reinforcement learning. I think some of you guys have heard this term. So this is basically what reinforcement learning is. A model trying to learn by interacting with an environment, and it receives rewards and penalties for the actions that it takes in that environment. So the ideal end objective of the model is to optimize its strategy to maximize the reward it gains and to minimize the penalties it gets. So a classic example would be training an AI to play a game. So in here, the AI learns the best strategy by playing the game repeatedly and receiving the rewards for winning or penalties for losing. So the end goal of the AI would be to maximize the rewards, and it would improve over the time with the gameplay. Right. Next, we all know that the AI has transformed our world in several key ways. So we'll take a look at what are kind of like key aspects that AI has played a major role, and we'll dive into each of them in deeper. So in the automation field, we are using AI to handle repetitive, labor-intensive tasks, boosting productivity and allowing humans to focus on more creative work. And AI helps in enhanced decision making. So AI can analyze vast amount of data, uncovering insights and patterns that helps to make better data-driven decisions. And when it comes to personalization, AI can tailor to customer experiences, like recommending products or content on social media, e-commerce, or in streaming platforms based on the user's behavior. When we are talking about the economic impact, AI drives the economic growth by creating new jobs and transforming industries like finance, manufacturing, and retail. As the final aspect, we have the complex problem solving. So the AI can tackle complex global challenges such as climate change, disease outbreaks by analyzing large data sets to find effective and efficient solutions. So in these ways, we can uh, conclude that AI have become an imperative aspect in our day-to-day and in the it has become a driving force of the modern world. In the coming sections, we'll discuss the impact of AI in several aspects of engineering. So I'll be discussing with you guys 5 use cases which covers different aspects of engineering. So as the first use case, I have chosen software engineering. In here, as the application, I have taken the chatbots and virtual assistants. So we are all familiar with ChatGPT, Gemini, and other customer service chatbots, right? So these tools use NLP or natural language processing to understand and respond to human language. So if we take a kind of like a deep dive behind what technologies are used inside these chatbots, we can see it uses deep learning techniques such as recurrent neural networks and transformers. A recurrent neural network or an RNN is basically a variant of a neural network which are specially designed to handle sequential data. Sequential data, if I give you an example of a sequential data is sentences, right? So they process one word at a time, maintaining a memory of previous words to understand the context of the whole sentence. In contrast to the RNNs, transformers are a much advanced model that can process entire sentence or paragraph at once. So this makes them much faster and more efficient compared to RNNs. So if we take like prominent LLM models like BERT or GPT, they are based on these transformers. Next, we can look at what are the NLP techniques used in chatbots are. So without before talking about NLP techniques, I'll give you a brief intro about what NLP is. Sorry, guys, are you guys asking any question? Do you guys have any questions, guys? All good.
Yeah, go ahead. Go ahead. I think.
Sure. Yes. Yes. Hi, NLP. Yeah, NLP is a subfield of AI, and it especially focuses on the interaction between humans and computers through natural human language. So previously, it was generated or kind of like introduced to understand the human language, but now it has evolved into kind of like generating the natural human language also. So under that techniques, we have natural language understanding. So this enables machines to understand and interpret human language. And we have the natural language generation, NLG. This allows machines to generate human-like text based on the input. And finally, we have the speech recognition and synthesis. So this basically converts the spoken language into text or the text back into spoken language. So these are the main technologies used behind the chatbots. And let's look at a simple workflow, simple foundational workflow for chat. So I have included an example here of ChatGPT aiding in software engineering. So I know all of we have used ChatGPT for coding, right? Right. So with that, let's talk about the foundational workflow of a chatbot. In here, in the foundational workflow of a chatbot, we can identify 4 main steps. The first one is the input processing. In here, the user inputs user inputs a user query through as text or voice. Then, if the user input is voice, the automatic speech recognition converts it to text. Then the second step is the understanding the query. The NLU processes the text or the user query and understand the intent and extract the entities. So by using this step, it understands what is the kind of like exact context or what you should actually mean by his query. And the system used kind of like pre-trained models like BERT or GP to gain this contextual understanding. The third step is the response generation. So it uses dialogue management component to determine appropriate action or the response. Then the NLG model generate the coherent and contextually relevant response, and that it moves to the response delivery step. In here, if the output is in text form, it is displayed to the user. And if the output is required in voice form, a text to speech model would convert the text response into speech. Okay. With that, we have come to our second use case. In here, I have taken the automotive engineering sector. So as the application, we have autonomous vehicles. So as you all know, autonomous vehicles, also known as self-driving cars, use AI sensors and advanced AI algorithm to navigate and drive without human intervention. So the importance of AVs are it promises to revolutionize the transportation by improving safety and reduces the traffic congestion and providing mobility solution to those unable to drive. Let's take a closer look at what are the driving technologies behind this autonomous vehicle. So the main driving technology behind these autonomous vehicles is the computer vision. So the computer vision is basically using cameras and image recognition algorithm to understand the vehicle's surrounding. So under computer vision, we are using techniques such as image recognition and semantic segmentation. In here, if I talk about image recognition, it's basically identifying objects like cars, pedestrians, and traffic lights to image recognition algorithm. Then, when we are talking about semantic segmentation is dividing the identified objects in the environment into segments. Let's say road, sidewalk, and obstacle. So you can see in the image on the right side, we have a environment and the model has identified the objects in the environment. And after doing semantic segmentation, it has divided the objects in the environment into segments. So we can see segments such as road, sidewalk, buildings, vehicles, fence, right? Then apart from the computer vision techniques, we are also using machine learning and deep learning techniques. So we are using neural networks for the tasks like such as object detection and behavior prediction. And we are using reinforcement learning to optimize the driving strategies through trial and error. And also we are using techniques such as sensor fusion. In here, what do you mean by sensor fusion is basically combining data from multiple sensors like cameras, LiDAR, short range radar, and long range radar to create a comprehensive view of the environment. Finally, the final technique we are using is the path planning. In here, AI algorithms are used to determine the best route from the best route from a starting point to the destination, while considering the safety and efficiency. So this is an overview of the multiple sensors that I have taken in my previous slide. So we can see long range radar, LiDAR, cameras, and both short, mid, and medium range radars. So all of these sensors come in handy when kind of determine the vehicle's location and getting detections about the surrounding. Then if we take a look about the workflow of autonomous vehicle, we can identify 5 main steps. The first step is the perception. In this step, the sensors cameras, lidars, radars collect data about vehicles surrounding. Then computer vision algorithms process the data to detect and classify objects. The second step is the localization. So it uses GPS, odometry, and sensor data to determine the vehicle's precise location. The third step is the planning. So in this step, the path planning algorithms generate a safe and efficient route from the starting point to the destination. So we are using behavioral planning algorithms to determine how the vehicle should respond to dynamic elements such as behavior of other cars and kind of like sudden movements of pedestrians. So we are using behavioral planning algorithms to determine those how we should take action into such dynamic elements. Then we have the control step. In here, algorithms send commands to vehicles actuators. So the actuators are basically uh, the steering, acceleration, and braking components of vehicle. So those are made by the actuators. And the control in the control step, algorithms send commands to vehicles actuators to follow the planned path. Finally, in the decision-making step, the model does a continuous assessment of the environment and make real-time decisions to ensure the safety and compliance with the traffic rules. Right. With that, we have come to our third use case. In here, I have taken biomedical engineering, and the application in the biomedical engineering is medical imaging. If I give a brief intro into what medical imaging is, in here we are using AI in medical imaging, which involves using machine learning and deep learning techniques to analyze medical images such as X-rays, MRIs for disease detection and diagnosis. This is important because it enhances the diagnostic accuracy and speeds up the analysis process and helps in early detection of diseases. Now, if we dig deeper into what are the technologies used in medical imaging, we can see it uses deep learning, machine learning, and natural language processing. So, in as deep learning techniques, it uses convolutional neural networks. So, what do we mean by a convolutional neural network? Convolutional neural network is a specialized variant of a neural network which is specialized for image analysis. So, using this CNN in medical imaging, it is capable to detect features like tumors, fractures, and lesions. And we are using transfer learning also. What do you mean by transfer learning is, say if we have a scenario where we are stuck with limited amounts of data. So in that case, we are using a pre-trained model to improve our diagnostic accuracy since we have a limited amount of data. So that's what do you mean by transfer learning, to be simply put. Next, we are using machine learning techniques such as supervised learning and unsupervised learning. So here, supervised learning is used to train models using labeled data to recognize patterns in medical images. And unsupervised learning is used to identify unknown patterns and anomalies without labeled data. And natural language processing used to analyze radiology reports and other patient reports to integrate this textual data with the imaging data to get a comprehensive diagnosis of the patient. So those are the technologies that use in the medical imaging. Now, if we move into basic workflow of how medical imaging works, we have 6 main steps. The first step is the image acquisition. In this step, medical images are captured using modalities. Like, what do you mean by modalities? Like basically the image capturing mechanisms of the machines. In this case, it would be X-ray, either X-ray machine, MRI machine, or CT scan machine. Then the second step is a pre-processing. In here, the images are enhanced and standardized for analysis. So we are doing noise reduction and normalization as preprocessing steps. And in the image analysis step, and AI algorithms, so basically the CNNs, analyzes the image to detect abnormalities and to classify tissues and to identify patterns. And the next step is the feature extraction. In this step, significant features such as, let's say, tumor boundaries or lesion size are extracted for further analysis. And in the fifth step, we do the diagnostic and report. In here, the predictions are made and the results are interpreted and the diagnostic reported are generated. And the final step is the review and validation. So since the patient diagnosis is kind of like a critical functionality, we need the final validation from domain expertise. In this case, we need the validation from either radiologist or qualified medical expertise like a doctor. So either doctor or radiologist would review the AI generated result for final validation and give the final diagnosis for the patient. Next, we have our fourth use case in here. I've selected cybersecurity engineering and our application is fraud detection. So what do you mean by fraud detection? So fraud detection involves identifying and preventing illegal activities such as unauthorized transactions by analyzing data for unusual patterns. Mainly this is used in financial sector and it helps financial institutes to protect assets, reduce losses, and to maintain the customer's trust. If we take a look at what are the technologies used behind this fraud detection, we can identify they are using both supervised and unsupervised learning. They are using supervised learning to train models using labeled historical transaction data to detect fraud, and they are using unsupervised learning to identify new unknown fraud patterns without the labeled data. And they are also using neural networks to analyze complex patterns in large data sets to detect anomalies, and they are using RNNs to capture temporal patterns in the transaction sequences. Also, they are using anomaly detection. So in here, techniques such as clustering and statistical methods are used to identify transactions that deviate from the normal behavior. And they are also using natural language processing to analyze textual data such as, let's say, transaction descriptions of transactions for any suspicious activities. Next, as usual, let's take a look at general workflow of fraud detection system. So in here, we can identify below steps. So first is the data collection step. In here, we gather data on past transactions, user behavior, and known fraud cases to build a comprehensive data set. So in this step, we are kind of like building a complete comprehensive data set on past transactions, user behavior, and known fraud cases from before. The second step is the pattern recognition. In here, machine learning algorithms analyze this data to identify normal patterns and user behavior. Normal transaction, basically, the patterns without suspicions. Okay. Then, in the third step, in the anomaly detection, it continuously monitor new transactions and new user activities, flagging any significant deviation from the previously established normalized user pattern, and any deviations would indicate a fraud. So such deviations would be flagged in this step. Then we are going to the risk scoring step. In here, we are assigning a risk score to each transaction based on their detected anomalies. So the higher risk score analyze that there's a higher likelihood of a fraud. Then as new data comes, we do the model refinement. So we do model refinement using confirmed data about confirmed fraud attempts, and by refining the model, we can fine-tune its algorithm and increase the accuracy and adapt it to emerging fraud attacks. Then the final step is the review and taking actions. So the transaction with high risk scores are flagged and they are being sent to be further analyzed by the system to financial instructors or someone who's overseeing this fraud detection system, and they may take action such as blocking the specific flagged transaction or alerting the system, alerting the users. All right. With that, we have come to our final use case. In here, I have picked the mechanical and mechatronics engineering aspect. So the application is the AI-powered bin picking. So guys who are doing mechanical or mechatronic, probably mechanical and mechatronic engineering would know what this bin picking is. And for the guys who don't know, I'll give you a brief introduction. Basically, bin picking, it involves using robots to identify and grasp and sort items from a bin or container. So it's commonly used in manufacturing and logistics. So the importance of this is it enhances the efficiency and accuracy in tasks such as assembly, sorting, and packaging, which are generally very repetitive and labor-intensive processes. Right? So it basically automates these processes using AI. If we take a look at the AI technologies used in this bin picking, the main technology used is computer vision. So in here we are using techniques such as object detection and depth sensing. In object detection, we identify items within the bin using cameras and image recognition algorithm. In depth sensing, we are using 3D cameras to measure the position and the orientation of the objects. Also, we are using supervised learning and reinforcement learning here. We are using supervised learning to train models with labeled data to recognize and classify objects, and we are using reinforcement learning to optimize the robot's grasping strategy by rewarding it. So it would learn through trial and error. And we are also using CNN as a part of the computer vision to analyze the visual data to detect and classify objects. And in some cases, we are also using generative adversarial networks, or commonly referred as GANs. GANs is a specialized variant of neural network which is used to create synthetic training data, in this case, to improve the model's robustness. Right. Next, in this slide, I have depicted the basic workflow of a bin picking system, bin picking robot arm. And if we kind of like go through the standard workflow of an AI-powered bin picking system, there are 7 main steps. The first step is the image acquisition. In here, cameras and 3D sensors are used to capture the images and the spatial data of the bin's content. Then we come to the data pre-processing step. In here, we pre-process the images to enhance the quality and to remove the noise. Next, we have the object detection and classification step. Here, we use an AI algorithm to analyze the images to detect and classify objects within the bin. The fourth step is the object localization step. Here, we determine the position and orientation of each object using depth data. The fifth step is the grasp planning. In here, the model plans the optimal grasping strategy based on the object's size and shape and orientation. The sixth step is the robot arm control. In here, our control system directs the robot's arms to execute the previously planned the grasp planning mechanism and move the object from the bin to the desired location. Finally, we have the feedback loop. In here, we do continuous monitoring of the process and adjust the strategy based on the success or the failure rate of the grasping actions. Right. With that, we have reached the conclusion of our session. So before wrapping up, I want to emphasize the special fact. So I want to emphasize the critical importance of data quality in AI application. So the success of these applications kind of like majorly depends on the quality of data they are trained on. So as you step into the industry and eventually build this application, so please ensure that you focus on acquiring and maintaining high quality data. So with that being said, I'm going to end this session. Thank you for all being here. So if you have any question, me and my team lead too will be here to answer them.
Thank you, Mr. Dulan Bamunuge, for your enlightening session. Now it's your turn to get involved. We'll open the floor for a Q&A session. Feel free to raise your hand or type your queries in the chat box.
Yes, yes, sir.
I think what are the qualification, that means like what are like some kind of a projects do we need to uh, qualify as a ML engineer or AI engineer, something like that? How can we put our foundation that as
Yeah,
what are the things we need to do?
yeah, I think my team lead would be able to give you an better answer for that thing, that question. Theo, over to you.
Yeah, hi guys, I'm Thiru. I'm head of AI at Rootcode. Um, I think your question is to enter into the industry as a machine learning engineer. What's expected? Is Did I get your question right?
Yes, yes, yes.
Yeah. So okay. Um, so to enter as a machine learning engineer, which is a senior position, I think we expect some industry experience working in ML and AI and really strong foundations. So that's for recruiting a machine learning engineer, which is a senior role. To enter into the industry, I think the usual approach is to get an internship. And for freshers, we expect passionate individuals who are put work towards their passion, right? So basically, what we expect is for you to know the fundamentals of AI and software engineering, because ML engineering is a combination of data science, software engineering, and data engineering, and DevOps all put together into one, right? And AI engineering too. So you should, as an ML engineer, you should be really good in programming and in building applications and building solutions and solving problems, especially from a backend point of view. And also you should be really knowledgeable in machine learning and models and training models and building data and model pipelines and so on. So best place to start would be somewhere like Kaggle, where you start building a set of, start solving a set of Kaggle problems. So Kaggle is an open data/AI engineering competition platform where you can go and take part in different competitions and solve different types of problems. Then ideally, the recommended path would be for you to uh, take do more portfolio projects. So you should try to find data sets online and build models and deploy those models, right? And when we as recruiters, we will evaluate you based on the projects you have done. So we will go deep into it and ask questions. So the more interesting projects you have, the better it is. So I think so the projects you do and the portfolio you have plus the how good are you in the fundamentals of AI and ML? That's what matters. Yeah, so I think that would be my answer.
Thank you. I think Vinujita, do you have any question? I think you raised the hand. You can unmute and ask the question.
Sir, as you mentioned, deep learning is one subset of machine learning. What are the other subsets of machine learning? Is it computer vision is subset of machine learning?
Dulan, you want to take that?
Yeah. Yeah, computer vision kind of like falls under as a subset of deep learning because it's like it involves convolutional neural networks, and so it's like more of a subset of a deep learning computer vision.
Just to add on that, I think computer vision has also over the time evolved a lot. So initially, when computer vision, like if you take before the CNNs in the early 90s, it was very algorithmic. Even now, certain algorithmic approaches are used. So to answer your question, I don't think computer vision falls under deep learning or machine learning, but it has an overlap. So computer vision is a field of its own. So computer vision is basically whenever you build applications or software or research solutions that use visual data, uh, then it's computer vision basically. And deep learning algorithms are just a better approach to solve computer vision problems. So I don't think you can group it under ML or DL, but it's more of a parallel field which has a lot of overlap with deep learning.
Sir, as a beginner for the AI, what is the better? What is the most better one to collect the data and create the machine learning model, or try on consisting data set?
Just to frame your question, your question is, for a beginner, what would be the best? What is it better to try to improve accuracy on the same data set or try different data sets? Is that your question?
Yes, sir.
Okay, I think both are really important. You shouldn't just keep trying out different data sets which are without trying to achieve good accuracy, right? So you learn from both. When you try to improve accuracy on the same data set, you learn how to architect models really well. Because see, machine learning and deep learning both, it's a science and an art at the same time to some extent, right? There's no one single equation that will give you the perfect number of layers to have in a neural network. So that's a learning experience. So even us in the industry, we learn it over time and over experience as we work with more and more data sets. So you shouldn't just go ahead and just try out different data sets with really bad accuracy. So you need to focus whatever data set you're working on, you need to make sure you get good accuracy there. But you also need to parallelly make sure you're focusing on different types of data as well, because a major part of working in data science or ML or AI is working with the data itself, right? Working with the model is just one part of it. A major part is actually figuring out meaning from the data, or building pipelines around the data. So you need to ideally do both. Yeah. I think somebody has mentioned a question in the chat. It is mentioned that some.
It's in the chat. I think.
It says it is mentioned that some software engineer skills want to become AI and ML engineer. If electrical and electronic engineer want to become AI and ML engineer, what are the fundamental software skills should learn? That's the question.
Yeah, so it's like basically, so that would be
I
like
think Dulan is a software engineer turned into a
sure.
AI engineer. He'll be able to answer better.
Yeah, so I came from software, as Tego mentioned, I came from software engineering background. I first started my career as software engineer, then I changed my career into as a machine learning engineer. So to answer your question, so basic software engineering skills that you want, do you need the kind of like good grasp in the programming, how the programming works, and get a kind of like good foundational and fundamental knowledge on data structures and data structures and algorithms, and mainly the mathematical aspects, such as so there's a course in Coursera, deep learning AI. The course name is Mathematics for Machine Learning and Data Science. You could follow that to gain the fundamental mathematics knowledge, because it would help you massively in understanding the deep concepts behind the deep concepts and the statistics behind some of the machine learning and deep learning algorithm. So to answer your question, first get a good grasp in the basic programming concepts, then move into data structures and algorithm, and then gain the mathematical knowledge. Do you guys have any other question?
Yes, sir. Am I audible?
Yes.
Sir, you talk about sensor fusion, right? So, are there any softwares to do that, or we have to do it by coding?
I think instead of software, kind of like softwares, there are kind of the hardwares to do the sensor fusion. To basically to get the all the data from the sensors, and to kind of like concatenate them, and to get a comprehensive idea of the or the imaging of the surrounding environment.
As we approach the end of our webinar, I would like to invite Shamodi Senarathan, the assistant of ERIC, to extend our gratitude to everyone who made this event possible. And before we wrap up, I'd like to remind everyone to stay on for a moment after the vote of thanks so that we can take a group photo. We'd love to capture this moment with all of you.
So, good evening, everyone. I'm Chamodi Senaratna, the Assistant Secretary of Electronic Robotics and Innovation Club of KDU. So, as we conclude this enlightening online session, it's my honor to extend a word of thanks. First and foremost, I would like to express our deepest gratitude to Mr. Dulan Bamunuge, Associate Machine Learning Engineer at Rootcode, and Mr. Thirunayan Dinesh for sharing their profound knowledge and insights on the impact of AI on the engineering sector, and the computing sector as well. Your expertise has not only broadened our understanding, but also inspired us to explore the limitless possibilities of AI in our field. Thank you, Mr. Dulan and Mr. Thirunayan, for taking the time to join us virtually and for your invaluable contribution to GENESIZ 24. I would also like to extend our sincere thanks to Rootcode for supporting this event and for their continuous efforts in advancing technology in both of our fields. Your support has been instrumental in making this session a success. A special thanks to our organizing team, the Electronics, Robotics and Innovation Club at KDU, for their hard work in ensuring that this online event ran smoothly. The commitment is truly commendable. I also want to acknowledge the co-chairs of GENESIZ 24, Mr. Kesara Hansaji and Mr. Isru Darshana, and the committee members as well. Actually, your leadership and meticulous planning have been crucial in bringing this event to life, even in the virtual space. So all your behind-the-scenes efforts are deeply appreciated. So last but not least, I would like to thank all the participants for their enthusiastic involvement and engagement. Your active participation has made the session more interactive and valuable. Thank you all once again and have a great evening ahead. Thank you.
Thank you, Shamoli, for your heartfelt words. We hope you enjoyed this session and found it both informative and inspiring. Once again, I thank you all for joining us. Stay tuned for more exciting events, and until next time, keep innovating and exploring your incredible world of AI. Have a wonderful evening and goodbye.